problem we are discussing. In the last class, we discussed about the radiation of heat transfer between parallel plates. We have discussed only the radiation of a parallel plate. What is the heat transfer from this plate to this plate? What is the in the radiation? What will be heat transfer from plate 1 to plate 2? Now we are going to discuss about a problem. If a radiation shield is placed between two parallel plates, these questions will be asked in the universities. Now take a question. The emissivity of two large plates maintaining at maintaining at 800 degrees Celsius and 300 degrees Celsius. Two large plates. Temperature T1 is 800 degrees Celsius. It is given in Celsius. In previous problem, the temperature is mentioned in Kelvin. And T2 equal to 300 degrees Celsius. Emissivity is given point and 0.5. Find the net radiant heat exchange per square meter. Find the net radiant heat exchange, which is P by Q. We have to find and find the percentage reduction in heat transfer when a polished aluminum radiation shield is placed between two parallel plates. The polished aluminum shield is placed between two parallel plates, and its emissivity is 0.06. Now, also find the temperature of the shield. We have to assume it is the third part, and we ask us to find the degree, and we ask to find the radiation, reduction in radiation, reduction right. So we want to calculate the heat transfer from plate 1 to plate 2. If there assume there is no radiation shield is kept between these two parallel plates. So our formula is Q12 equal to, what is the formula? 1 by so this is our heat transfer formula. When the radiation shield is without radiation shield, it is heat transfer from 1 to 2. This is the formula. And for calculating the emissivity, it is 1 by, so now plus 1 by equal to what is the formula here? T 1 power 4 minus T 3 power 4. Very good. And for epsilon emissivity, total emissivity 1 by
plus 1 by 3.
Do you have all the other values? You have emissivity for 1, you have emissivity for 3, and you can substitute in this formula and you can calculate. Tell me the value and substitute the value here. Listen. Here only one unknown value, which is T3. Take it as Q by A. Here also you can calculate Q by A alone. Because the area is not given, so we have to calculate the heat per square meter. Heat transfer per square meter. Here also you have to calculate the area will come down this and substitute all the other values. You get a value in terms of T3. Right? And now take Q32. What is the formula for Q32? Heat transfer formula. Emissivity, Stephen Boltzmann constant, area. What is the formula now? T3 power 4 minus T2 power 4. Right? So here for emissivity it is 1 by 1. 3
plus
1
by minus 1.
So substitute here and you get the value for emissivity. Then substitute the emissivity here and you get it. So equate these two equations. In terms of 3 power 4, this is also in terms of 3 power 4. Both the terms are right. Equate these two terms and you get the value for T3. So substitute the T3 value. If you get the T3 value, then it is possible to calculate what is the heat transfer from 1 to 3 and what is the heat transfer from 3 to 2. Right. First thing, calculate the heat transfer of 1 to 3 from the panel from the one temper plate 1 to the radiation shield. This is the radiation shield to the next plate. Plate number 2. So calculate the Q by A for these two terms and then compare these two equations and tell me the T3 value. We can substitute. We know that Q heat transfer 1 to 3 equal to 3 to 2. Right? So 1 to 3 I am writing the equation like this. The epsilon value is determined by like that. So it comes denominator. So we know the values. Substitute the denominator, you get the values for denominator. You can cancel these two values. So then a new equation what is the value for this? Will be the value for that
0.0526.
and you get a value for this. So substitute the values here and calculate the T3. 20.6 here divided 20.6 T1 power 4 minus T3 4 divided by
Sir,
hmm,
அது T3 out T2
19
T3 controls. அது எத்தனை
and this side is
ஒரு T3
plus T2 power 4. We substitute பண்ண then substitute the values here T1 T2 substitute பண்ண you get the values. So you get a term like this, then what you have to go, then substitute the T1 value, T2 value, then you get a equation like this, T3 power 4 equal to 1.335 to 10 to the power 12 minus 0.962, multiply the 0.926 T3 power 4. Then take the value here. So you get here T3 power 4 or 912 kg. You get a T3 value of 912. Listen here, if we substitute in this equation, we get a T3. Only unknown in the equation is T3. Only unknown term is T3. Substitute in the formula and you get a value for T3 is 912. After getting the value, you can substitute in the heat transfer from 1 to radiation sheet and then radiation sheet to second grade. Now what we have to calculate? 1 length 3. We have to calculate what is the heat transfer from 3 to 2. We have to calculate the heat transfer from 3 to 2. So calculate the 3 to 2 value and then compare these